What makes an application really successful? What are the best practices while building one? Our next speaker will take us into a journey to cloud native technologies and applications. She's a product manager who, in the past few years, worked to build innovative platforms based on cloud native technologies. She helped to enable Nokia telco applications to seamlessly integrate with any cloud. As a PM, she drove customer requirements to choose the best solution for their complex use cases. With this speech, Cloud Native and Best Practices to Build a Successful Application from Ottawa, Canada, let's welcome Noura Daadaa.
Hi, everyone. Thank you for hosting me in this great and awesome event. So I'm very honored to be part of that. So my name is Noura Daadaa, and I'm so excited to start with you discussing the best practices for building an application in cloud native infrastructure. So a background, I have been working in Nokia for 10 years, and through these years, we have collected different feedback and practices to deploy successful applications using the best practices of cloud native. So on this journey, let's start. So as a best practice or a fundamental principle that good product and application team really care about the customer use case, and they want to make sure that everything they develop and deploy that makes sense. And often decision makers shy a little bit practicing some of the requirements or questioning some of the requirements, as some of those questions tend to be a bit more technical. In this talk, we're going to talk about how business and technical requirements blend with each other. So then when an engineer facing customers, getting those business requirements, match it to some technical fundamentals and principle, and making sure building an application can be successful for the deployments in the future. So cloud native principles blend a lot between design and architecture. And when receiving requirements for any product or any customers, it's very important to understand what is the difference between the SLO, SLA, and SLI. We're going to talk a little bit about them. And then we're going to see how can we make sure when we develop and design an application that it matches those requirements, and also built to make sure that the customer always succeeds in their use cases. So the very fundamental question as a product manager or as an architect facing customers is ask a very important questions. So why are we developing this feature? What are the core value that we're bringing by deploying a certain functionality in that product? Is this functionality or requirement we receive going to drive value and revenue for the customers? Is this good for the product for a short and long term? And what are the things that we should never do? Because some of the questions, sometimes engineers feel like they have to do trade-offs between a requirement as is or versus trying to study it and understand what's the consequences, what are the gain, what are the losses for such development. And the goal at the end of the day is to enable the product team, such as research and development or even engineers on site, to build a product from an idea to something you can bring it to production. And bringing a product into production means that this product have to meet a certain commercial agreements and service level agreements and certain quality aspects, and scale when it's needed and shrink back when it's not. So you can save on the cost and make sure you have a good return of investment when you decided to go for this type of deployments. So it's very important for any product manager or engineers on field to question those type of requirements that we receive often in our day-to-day job, and make sure that when this feature is decided to be done, it brings value to the product and make sure the customer is satisfied and deliver at the end of the day the meaning for why we are doing that. So make sure that first the question very carefully and have these meaningful discussions with the key stakeholders. And then for any decision maker, when they try to build an application, mainly And I see that often when there is often new ideas or new deployments, there is often those type of trade-offs. And what are the things that we measure? Often there is a three key values or wealth we have in an industry overall, which is the time, the budget, and the people. So for any decision you try to make when you build a product or create a feature or develop anything within the life cycle management for the product itself, we ask how many feature do we need with this certain period of time, and what are the budget? Is it one feature going to cost us the same amount of developing 10 small ones? Do we have enough people to cover those type of requests? Do we have the enough budget to make sure that we can do what we are promising? So there's a lot of criteria that any decision maker need to think before committing, is to study well the time, the budget, and people for any of the features that being developed for that particular product, and make sure that you collect the information as much as possible so we can drive at the end of the day a successful use case from the start to the end, and do a good study about wins and losses. So when we have to do trade-offs between budget, time, or people, we say if we don't do certain application, or we don't have a certain development skills, or we don't have the tools at this time being, what are we winning and what are we losing? And which feature can be implemented now and which feature can be implemented later to make sure our customers succeed and we can continue developing cutting edge product. Um, and one of the most key important when you evaluate time, budget, and people is also understand very clearly what are the things that we should never do as a product team, because developing successful application, sometimes you require to make a tough decisions and difficult calls where you sometimes have to deliver something short term, and then over time you can build it. So those type of things need to be studied very well, and make sure when we take those type of decision is a collective understood from both the consumer and the vendor. Um, for any development, for any of the applications that engineers evaluate, that any decision or any goal you have to do, it have to be smart. And the term smart in technology refer to features that have to be specific. Basically, this particular application have to have a specific goal, it have to have a significant, it have to have meaning, and it have to be simple. And really, at the end of the day, when a product is simple, understood, people can understand it clearly, you understand the use case, that's what makes a product successful and attractive. And the second one is measurable. So when you develop a feature or a product and you bring it from the idea into practice, we have to find a way where we can measure our success, where we have measured our goal and we measure our progress. So we make sure that we are progressing toward our end goal. And then if there is anything deviate from those measurements or those KPIs that we measure our success on, we can take action and correct our direction. And most important one is to make sure that building a product or building an application in a cloud native also sometimes receive a requirement that not necessarily achievable. And there is a big trade-off between what's achievable or what is not achievable in the current domain, but it's doable in the future. So those type of trade-offs to say this particular design is achievable, it's agreed on, design, architecture, customer, the whole collective team is agreeing and understood what are the key things that we can achieve and we can measure ourselves and our success for that application to be built on. And relevant, the R is basically this particular goal or work we are designing in our product is actually realistic. We can make sure when we develop something, we make sure we can measure it and bring results back to make sure that we are developing something actually have results, is reasonable. We can make sure that we can read and analyze if we are going in the right direction or not. And finally, time bound. So make sure you time box particular feature or work stream. So basically, any development, sometimes feature can start from idea. You do, like a little spike. try it in the lab, bring it into another, deployment or production lab, and build it from there. But at some cases, those type of scenario drag the life cycle of the development a bit longer. So important for the success is to make sure that those type of decisions is being time-based. So make sure that the feature are time limited in terms of the actual amount of effort being spent on, and also the cost, how many people we have to engage for this type of feature, for how long this development have to be carried off, and so on. So make sure when you're designing or discussing any requirement for a new product or feature in a cloud native or any new topic, any decision that should be made is based on those SMART criteria. Now, talking about business criteria and requirements we receive, and often there is a gray area between an SLA, an SLO, and SLI. So what I would like to describe here is when we define the use cases and the requirement, which is based on SMART, we have to do a certain measurements and KPI to make sure we are going toward our end goal. So the service level indicator is not necessarily what the team is agreed on in terms of development for this application on field, but it's a way to say, this is I'm developing application X, and during my development in cloud native, it could be in my labs or in customer's lab, I have to find a way to do a measurement through maybe measuring the throughput or measuring the latency, see how much errors I'm getting during the deployment. So I can get something measurable. I can make sure that I am still on track, and the service level, it's kind of be, I'm able to measure as we go. But doesn't mean that that's what the feature or the product is necessarily agreed on. So there is another thing called the service level objectives, which is normally this is the target or the end goal when you try to build an application. Make sure that you have basically a range of values or range of goals, and say my end goal is to reach there. It's normally a high objective achievable over time necessarily, or little bit, I would say, sometimes not necessarily right away, but let's say the goal is to reach to maybe 100%. But what you negotiate with the customers or with your team is something that driven from the commercial side, which is the service level agreement, which is really defining the service between what we are delivering as an application versus what the customer or the consumer is getting. So it's a responsibility to make sure that when we design the application, it meets the SLA. For example, the service have to always meet particular demand and always available according to the SLA. The SLO can be higher than the SLA. Basically, your objective is to bypass the SLA and make sure it's higher than what's agreed on. But when you do this kind of trade-offs and decision-making, make sure that the team understand that the objective is always higher. The SLA is kind of the agreement or the commercial aspect of the product, and the SLI should be always there to make sure you are measuring where do we stand from this life cycle when we're building a successful application that is new for the team. Now, in modern technology, now since we understand what is the key business aspect of when I need to develop an application, I need to consider the requirements. Requirements have to be smart. We understood what are the SLI, SLO, and SLA agreements. And in the same time, we have heard a lot about the 12 factors. And the idea is in the modern technology or the era we live in, most of our applications or the web-based application delivered as a service. So now you heard application as a service, network as a service, and so on. And this is very key important aspect because the 12-factor kind of technology Bible, if I have to say, it is methodology to make sure when you're building an application, and mainly cloud native application, that bring value and make sure that consumer can focus on what they do best and offload some of the things that sometimes consume time to something that exists on common platforms today. So the idea for this 12 factor is building a software that is declarative, so means that the software have to be automated, it scale up and down when needed and when not needed, and make sure that it sees that the investors will see the return of investment, because if application builds on those type of 12 factors, there is efficiency on the way how those applications is deployed on the customer side, and as well on the labs, which is the internal development environment. Um, there is also supposed to be a clean cut or a clean definition. What is the underlying operation system? And when we see the microservices architecture, assuming that there's supposed to be some sort of abstraction between the application and the underlying system. So it's very important when you consider building an application in cloud native to consider that you have to isolate the functionality and make sure it have less dependency on the underneath infrastructure. And maximum portability is basically the same way you execute and deploy the application on the environment and deployment lab, you can take it as is to the customer environment. So those are, we're going to talk about them as a part of the best practices in the upcoming few slides. And that would drive the actual value for the applications when taking it to cloud native. So my favorite infrastructure of all places is London. So this is something I was thinking about. When you take the train there, you always mind the gap. But as a designer or architect or even product manager, you should always mind the 12 factors. And this makes sense because while you're taking in consideration those best practices, you ensure you're going to deliver a successful application that can return your investment over time. So we're going to talk a little bit about those 12 factors. So the best practices when we deploying an application in cloud native, we talk about versioning. So make sure that the application is properly tracked, properly versioned. So when we talk about the CI/CD and DevOps in cloud native, often teams submit codes, and often, there is always a new feature coming. So it's very important to keep versioning and make sure there is, no sudden deprecation of certain APIs. So there is a certain kind of line of standard where code, and there is differently infinite amount of tools actually out there to help you monitor and see what are the best way to monitor my code and version it and make sure we can deliver something that is keep track on. The second one is dependency. When you develop an application or deploy it, there is some sort sometimes of dependency declaration or dependency isolation. So you either develop your application with dependency in mind, that you take it from somewhere else, could be an infrastructure, or you can bring your own dependency and isolate it in as part of their application. So it's important to keep in mind that dependency should always be there. Like some applications, when they talk about cloud native deployment, they wanted particular operation system or particular tool from the infrastructure. So important that those kind of criteria should be defined before the start. In terms of the configuration, the third one is the configuration. So any type of configuration for the system shouldn't be pushed in the code. So the idea is the environment should be kept separate from the applications, and which that the user have flexibility to add, edit, update in the future. Backing services, basically every services have to be isolated by itself. So the idea is, for example, deliver particular service, that service have its own database, and that service, if something happened to that service, you can basically restore it by its own. So the idea is to have the ability to restore particular service and make sure there is backup policies and architecturally studied well for where are we doing those type of backing. The fifth one is the rollback. Actually, this is, nobody likes to see a rollback in production, but the idea is when you keep that in mind, you ensure is if you introduce any feature or any new functionality in your application, you can still roll it back without impacting the rest of the customers or consumer or users for those applications. So keep those in mind. And the idea is if application built bottom up, taking into consideration those 12 factors, there is assurance that your application can never, have troubles in production, and try to minimize those type of surprises when you introduce new functionalities on field. The sixth one is processes. It's some applications we see it, if it's a web base, it doesn't have a state, so that's perfect. But there is some applications which have some sticky information like session information, so it needs to be maintained. So there's various technologies and component in the cloud native world where a developer can use and take that into mind, not just try to convert the application as is, but try to use what's available from there and invent and contribute to the community as well if something does not exist. So those are the first group. The second group, which also summarize what are the things that we need to expose. So here the requirement or the factor number 7, which is the port binding. Basically, the idea is when every service is exposed by a separate port, the idea is, there is no kind of an overlap between the services. So you ensure that every service is exposed using certain ports, is properly controlled, properly managed. Concurrency, basically, when a process, for example, you have an event or a game and your application, all of a sudden there is a spike and there is a lot of users wanted to use it. So the idea is your application should be able to scale and make sure to cover the demand for that momentum. And when there is no need anymore, the application should be scaled down. So those are not necessarily a luxurious feature. It's something that actually we do and we live every day. Like there is some applications most of us use today. Decided, for example, there is some event, people use their app, and in the back end, all these type of workflow happen behind the scene. It's very important when you're designing an application for cloud native to take in consideration those use cases. And number 9, disposability. So we talked earlier about the ability to scale out and grow when needed, but let's assume an event finish and everybody goes home and there is no demand for something that you use in your phone or your web. So the idea is to be able to shrink back and save energy and make sure that the relying infrastructure, you are not consume something that is not needed anymore, which is a very key factor for service provider, because when they invest in an application, they want to make sure they see the return of investment, the total cost of operation is reduced, because all of those life cycle events happen automatically. So there is no need for a human intervention to somebody manually try to shrink or grow your application when needed. So all these happen automatically. And number 10, which is very important, we often see deviation between the development environment and production. So the team create awesome application, work perfect in the lab. The moment you bring it into production and things start to show up. And this is often because there is a deviation between production and lab. So the idea is bringing this feature parity and use what is best, make sure that environment in the development is very similar to what the application can face in field. This ensure that a use case can successfully be built from the start to the end. The logs is a great and vital tool that provide awareness and health status for the application. So when designing an application, make sure there is certain design recommendation to make sure, maybe consolidate them somewhere, make sure you have a proper visualization and alerts if something happened in the system. So it gives you a proper measurements to see what's going on in the system. Often when those 12 factors and application built in microservices, application in the monolith, they used to be composed of maybe 4 to 6 to 10 server. In the microservices, maybe 100 microservices or sometimes even more. When you put it in production, even it scale automatically. So the more you divided your system to smaller pieces, the more you need to know what exactly happening to the system, and if something happened, where you can troubleshoot it. So it's very vital to make sure that those microservices that built correctly and have a log and a way to measure the success and the health status of their system overall. In terms of admin processes, it's always a good idea to make sure that there is certain functionalities only require admin processes, and often the idea is we don't intend to encourage using some admin privilege. So the idea is there is supposedly to be a decomposition between what application as a user can do versus what admin should be do. So in the monolith day where application is built on a actual hardware and somebody have to be on site, install the firmware and put the operation system and application. I mean, at the end of the day, everything starts from admin to be responsible from the start to the end. With cloud native practices, there is a very clear IAM policies about who can do what in which resources. So these type of criteria in mind ensure that your application is built with the security in mind and ensure that there is no extra privilege need to be given to application that not necessarily needed. So building this type of, or thinking about those type of criteria from the beginning is very useful when building web app or application as to be as a software as a service. And of course, with what we have today in the market, there is a lot of awesome platforms and technologies that help applications to build those great use cases. So feel free to check those 12 factor requirements or 12 factor guidance to see what are the criteria or the big practices that we need to do when we onboard and prepare our applications to be operated as a software as a service. So with that, I summarize the best practices, and that will be the session for today.
Noura, thank you very much for your great presentation.